Welcome to this video on two challenging GCSE questions about sequences. The question on this screen is about quadratic sequences. Okay, now in the first part here we're asked to find the sixth term of a sequence given that its general rule is of the form an squared plus bn. In other words, it's a quadratic sequence. The second term is -2 and the fourth term is 12. Okay, now what we need to do is some algebraic process. We shouldn't be doing any guesswork here. So what I'm going to do is say, well, when we're talking about the second term, n is 2, all right? And when n is 2, the value of the sequence is -2. So we'll start with that. So I'm going to say when n equals 2, okay, we know that a times 2 squared, so a times 2 squared, okay, plus b times 2 is equal to the second term of the sequence, which they tell us is -2. So if we just simplify that a little bit, we get that 4a, okay, plus 2b equals -2. And that's an equation linking a and b. Okay, we don't know what a and b are from that because there could be any number of possibilities at this point. So I'm going to call that equation 1. We're now going to create another equation linking a and b because we know that when n is 4, in other words, on the fourth term of the sequence, we know that that's 12. So when n is 4, we get a times 4 squared plus b times 4, and that gives us 12. If we rearrange that one, or simplify it rather, we get 16a plus 4b equals 12. Okay, that's a b there, not a 6. Okay, just be careful with that. And that's equation 2. Okay, good. So what we're now going to do is eliminate b from here, and we can easily do that if we double the first equation so it also contains 4b. So I'm going to take equation 1 and I'm going to multiply it by 2, the whole equation, you see. So that equation becomes 8a, so I'm just doubling equation 1, plus 4b equals -4. And I'm going to call that equation 3. Okay, now because that contains 4b and equation 2 also contains 4b, if I subtract the two equations from each other, I'll eliminate the b term and just have an equation in a, which I can solve. So I'm going to do equation 2 subtract 3, like that. I'm subtracting this equation from this one. 16a minus 8a is 8a. 4b minus 4b is 0. 12 take away -4 is 12 plus 4, which is 16. Well, if 8a is 16, it follows that a must equal 2. Okay, now I can take that value of a, substitute it into any of these equations I've made to find b. I'm going to substitute it into 1 because that's the simplest looking equation. So I'm going to substitute, okay, a equals 2 into equation 1, and that's going to give me 4 times 2 plus 2b, because that's what I'm trying to find, the value of b, equals -2. Well, 4 times 2 is 8, so I've got 8 plus 2b is -2. So if I subtract 8 from both sides, I'll get that 2b equals -2 minus 8, which is -10. Okay, I'm just subtracting 8 from both sides. Well, if 2b is -10, then b must be minus 5. Okay, so what I've done is I've found the values of a and b in the general rule for the sequence. So I know what a and b are in here, so I can rewrite this thing here as, from what I've just done, as 2n squared, okay, minus 5n as the general rule for the sequence. And now that I've got that, I can find the sixth term, or indeed any term in the sequence. So I'm just going to substitute n equals 6, and that's going to give me 2 times 6 squared. In other words, 2 times 36 minus 5 times 6. Okay, well that's 72 minus 30, which is equal to 42. Okay, and that will be the sixth term in that quadratic sequence. Okay, now the second part of the question is about a different quadratic sequence, and here it is. Okay, and what I'm going to do is I'm going to use the algebraic method to solve this one to find the nth term rule for this sequence. Now look, it's a quadratic sequence because the second difference, we've got here 8. So the first difference is 8 there, it's 6 here, it's 4 here, it's 2 here. Okay, and what we need to know is the 0th term if we're going to use the algebraic method. Well, that's easy because if I just number n at the top here, so this is n, 1 for the first term, 2 for the second, 3 for the third, and so on. So these are the values of n. I want to know what happens when n is 0. In other words, the term that would be immediately before the start of the sequence. Well, if you follow this pattern down, 8, 6, 4, 2, the difference here must be 0, which will actually make the 0th term also 0. So it's actually going to be quite easy to sort out. Okay, and we know that the general form of a quadratic sequence is an squared plus bn plus c. Okay, now in this case c was 0, and in fact that's going to happen in this sequence as well, because when n is 0, okay, so we're going to look at 3 conditions now. When n is 0, n is 1, and when n is 2. So when n is 0, we have that the 0a plus 0b, so it's really simple because it's 0a plus 0b plus c equals 0, because the 0th term is also 0. So basically we know that c is 0, so that's easy. Now when n is 1, okay, we have that a times 1 squared, in other words 1a, plus b times 1, okay, plus 0, which is c, equals the first term of the sequence, which is also 0. Okay, so 1a plus 1b equals 0. So a plus b equals 0, okay, is one of our equations. Okay, equation 1. And now we look at when n is 2. Okay, the second term in the sequence. Well, when n is 2, a times 2 squared plus b times 2 plus c, which is 0, gives us the second term in the sequence, which is 2. Okay, so just tidying that up, we get 4a plus 2b equals 2. Okay, and I'm going to call that equation 2. Well, if we double the first one, So 2 times equation 1, that will give us an equation that contains 2b as well. So we get 2a plus 2b equals 0. And we call that equation 3. And if we subtract equation 2, take away equation 3, we will get rid of the b term. So equation 2 take away equation 3 would give us, that's supposed to be a 3 there, let me just tidy that up a bit. Equation 2 take away equation 3, well, 4a take away 2a is 2a, 2b take away 2b is 0, and 2 take away 0 is 2. So 2a equals 2, which means that a must be 1. Okay, and we can straight away see that b must be negative 1, because we know that a plus b is 0, you see. So if a is 1, b is negative 1. Okay, and that takes us straight to the answer we need, because that means that if in our general formula we know c is 0, a is 1, so the general formula is 1n squared, or just n squared, okay, plus b times n, which is minus 1 times n, so it's minus n, and then c is 0. So it's n squared minus n. Now, in fact, if you look at the sequence, you can see that's right, because when n is 1, 1 squared minus 1 is 0. When n is 2, 2 squared minus 2 is 2. When n is 3, 3 squared minus 3 is 6. 4 squared minus 4 is 12. It's actually quite easy to see that it works, but nevertheless, you should show how you got the answer, because it says find an expression in terms of n. Okay, so you shouldn't be guessing it and testing it out. You need to work it out like we've done here. And there it is. Okay, so that was a question about quadratic sequences, but quite a tricky one compared with some of the questions that you might get. Let's look at the next one. This is an interesting question about a geometric sequence. Okay, so this is one where to get from one term to the next, you have to multiply by a number we call the common ratio. So the first 3 terms of a sequence are root x minus 1. Okay, the second term is x, and the third term is root x plus 1. All right, now the way to go about this is to understand what's going on in a geometric sequence, and to get from one term to the next, you have to multiply by something. And to get from that term to the next, you've got to multiply by the same thing. So in other words, if we go backwards, if I divide that by that, I get the same answer as if I divide that by that. And by the way, this number in the middle here, which I've written down as x, should actually be 1. Okay, so that divided by 1 is the same as 1 divided by that. Okay, so let's now proceed with forming an equation that we can solve. So I'm going to take the second term divided by the first. So 1 divided by root x minus 1, okay, must equal root x plus 1 divided by 1. I'll just write it down as divide by 1, but obviously you wouldn't need to, because dividing by 1 leaves it unchanged. Now if we just cross multiply, in other words, I multiply both sides by 1 and then by root x minus 1, it follows that 1 is equal to root x plus 1 times root x minus 1. Okay, and if we do what we call FOIL, first, outer, inner, last, on this, we've got that 1 is equal to, well, the first term, root x times root x is x. Okay, the outer term is minus 1 times root x, and plus 1 is the inner term times root x. So that times that is minus root x, and that times that is plus root x. But when you combine them, they cancel out. So you're left with just the first term, which is x, and the last term, which is 1 times minus 1, which is minus 1. Well, if 1 equals x minus 1, then it follows that x must be 2. Just add 1 to both sides. And it says find the value of x, you must show all your working. So I've just done that to get the first part of the question answered. Now, show that the fifth term of the sequence is this. Now, the best way to do this is actually, because we've got the first 3 terms, okay, we've just got to find the fifth, and I would suggest the best way is to find the fourth, then the fifth, okay, rather than try and go straight to the fifth. And this is what I would do, okay. I would say that the fourth term is, so the third term is root x, so third term is root x plus 1, which is root 2 plus 1. Okay, because you've just found what x is. That was the third term. Now we need to take that term and multiply it by something to get the next term. Okay, and we know that the common ratio of this sequence now is root 2 plus 1. And the reason we know that is because to get from the second term to the third term, if the second term was 1, in order to get this term, I had to multiply 1 by something. Well, obviously, to get from 1 to that, I had to multiply by root 2 plus 1. Okay, so the fact that one of the terms is 1 has made this really easy for us. So I'm just going to illustrate that. So what have I had to multiply 1 by to get the next term? Well, clearly you can see that I've had to multiply it by root 2 plus 1. So the third term is root 2 plus 1. So the fourth term is going to be the third term multiplied by root 2 plus 1. So it's going to be root 2 plus 1 times itself. Okay. Now, if you use FOIL again, you get root 2 times root 2 is 2 first. Okay. The outer term is 1 root 2. The inner term is 1 root 2. So that's going to give me 2 root 2. And the last term is going to be 1 times 1, which is 1. If you simplify that, you've got 2 plus 2 root 2 plus 1, which is 3 plus 2 root 2. That's the fourth term. Now, because this is a geometric sequence, to get the fifth term, I take the fourth term, okay, and I multiply that by root 2 plus 1. So there's the fourth term, 3 plus 2 root 2, okay, and I multiply that by the common ratio, which is root 2 plus 1. Okay, and again using FOIL, first, outer, inner, last. The first term, 3 times root 2 is 3 root 2. the inner and outer term. The outer term is 3 times 1, which is 3. That's the outer term there. You see the inner term is 2 times root 2 times root 2. Well, if you take root 2 times root 2, you get 2. So it's 2 times 2, which is 4. Okay, and the last term is root 2 rather times 1, which is 2 root 2. Okay, now combine all that together. You've got 3 plus 4 is 7. Okay, and you've got 3 root 2 plus 2 root 2, which is 5 root 2. And as you can see from the question, it said, show that the fifth term of the sequence is 7 plus 5 root 2, which is precisely what we've just done. Okay, so there's your working out, or one method of working it out. That's a difficult question, that one, and that's certainly touching on the top end of GCSE. That'll be a grade 9 question. Okay, I hope that was helpful. Take care.